How many ordered pairs x, y satisfy the system of equations above? So let's examine the equations given. We have a linear function here, and we have a quadratic equation right here. Now, if we were going to use the substitution method, this would be a little bit cumbersome because we would have to take this x value, plug it here, and that would be a pretty complicated looking equation. So I'm going to suggest, because we're not being asked for actual answers, we're just being asked how many answers we'd have, to rather than solve this, we just want to visualize it. So let's start with this quadratic equation. So let's create a little x and y plane here. If you were going to solve for each of these, 2x minus 3 equals 0, x would end up being 3 over 2. So that means, x is 1.5. We are crossing the x-axis where x is 1.5. So right around here. And then if you're going to solve for the second one, it says x plus 9 equals 0. So x would be negative 9. That means we're crossing the x-axis also at negative 9. So we're crossing over here. And since the leading coefficient is a positive number, we know that we're going to have a U-shaped graph that sort of looks like that. Next, we can look at this top equation, which is the linear function right here. It says x equals 2y plus 5, but it's not in the correct order, right? So remember, if you're going to solve, or rather graph a linear function, it needs to be in the form y equals mx plus b. So let's get y by itself. We're going to start off by subtracting 5 from both sides. Therefore, we'll have 2y equals x minus 5. And then we can divide each side by 2 all the way through. So y equals 1 over 2x minus 2.5. So that means our y-intercept is 2.5. So wherever the y value is 2.5, right around here. And then we're going to go up one place over 2. Up one place over 2. So all we need is a sketch. The graph doesn't have to be perfect. And we can see that we have a line that sort of looks like that. And the solution is where the two graphs intersect. Well, we can see a clear point of intersection here and a clear point of intersection there, which means we are going to have two ordered pairs that satisfy the system. So C would be the answer to this question.